We'll begin with efficient workflows to create this flanged pipe elbow, then explore both manual and automated methods to produce this drawing. Keyboard shortcuts appear at the bottom left corner whenever used. Let's get started by creating a new component. We'll begin within the activated component by sketching on the horizontal construction plane, starting with a center diameter sketch. The focus of this project is to demonstrate the workflow, so we won't be optimizing this pipe flange elbow for specific conditions, prerequisites, or design standards. Center your diameter sketch directly at the origin to take full advantage of a centralized design. We'll explore practical benefits of this approach later in the Fusion tutorial. The dimension I'm using, 50 mm, isn't critical to the workflow, so feel free to use your own measurements. The smaller circle represents the bolt holes for a secure connection. I'm keeping the sketch simple by adding just one circle. Later, we'll use a circular pattern to distribute the holes. Simplifying the sketch and relying on solid modeling commands keeps your design easier to manage and edit down the line. Here's a quick time-saving tip. Jump straight from the sketch environment to the Extrude command using keyboard shortcuts. No need to close the sketch first. You can extrude in either direction and adjust the thickness to suit your design. To distribute the bolt holes, use the circular pattern with the object type set to faces. It's easy to center the pattern around the model using the predefined blue axis at the middle of the design. If you're having trouble spotting the correct axis, use the Orbit tool or View Cube to reorient your view. I'll set the bolt hole count to 6 and keep the distribution set to full, ensuring the holes are evenly spaced. We'll start a new sketch directly on the solid body. This sketch serves two purposes: finishing the design of this part and setting up a connection point for assembling the two parts later in the workflow. Begin by sketching a circle for the hole. Then offset it with another circle positioned 2.5 mm outside the first. This way, if you adjust the inner circle, the outer one updates automatically. For the extrude cut, I'll simply select the bottom face of the model, quick and efficient for a prototype like this. Make it a habit to check your model from different angles regularly to ensure everything aligns as intended. Next, we'll move and copy the body inside the component. Notice that we're working within the component itself. This is different from moving or copying the entire component. Bodies versus components are outside the scope of this tutorial, but both workflows have their place depending on the project. For more detailed projects, especially those involving joints or parts you'd reuse in other designs, I'd recommend copying the base as its own component and creating a separate component for the connecting pipe, then connecting them with joints as needed. The parts are neatly lined up and we'll connect them using a 3D sketch. I'm using the line tool because it snaps cleanly to the existing geometry, making it easier to connect the pipes with the solid body later. Of course, you can also use splines or arcs if that suits your design better. Don't worry if you don't hit the exact spot when sketching. Simply extend the line beyond the geometry and trim away the excess. The sharp 90-degree angle is just temporary. We'll refine it later to create a smoother radius. The keyboard shortcut F is assigned to the solid modeling Fillet command, so instead, I'm using the sketch shortcut to activate Fillet. A 25 mm radius works well for now, and we can always adjust it later through the Fusion timeline if the solid model doesn't look quite right. Now is a good time to save your project. The version number will automatically update once you continue working after saving. Make sure Sketch 2 is visible before activating the sweep command. We'll use the offset circle created around the 2-minute 30-second mark. Since we're working with a closed profile, we can use the solid modeling sweep, just select the profile and the path. I'm leaving this as a join operation, but as discussed briefly regarding bodies versus components, there are other workflows that might be more optimal depending on the situation. A quick check from different angles confirms we're on the right track. It's always a good idea to inspect your model like this, especially when using 3D splines. While splines offer more flexibility and precision, in my experience, they're also easier to misplace compared to simple lines when 3D sketching. A polished brass appearance will look great, and since everything is joined into a single body, we only need to apply it to that one body. These fillets will give a welded look. If we were making a real product instead of a rapid prototype, we'd need to ensure the bolt holes aren't too close to the welds. This simple detail adds a realistic touch to a welded design. As for the drawing setup, Fusion offers both automatic and manual drawings. You can start from scratch or use a template. In this tutorial, we'll create a manual drawing but incorporate some automated parts, so stick around. The drawing opens in a new file, which makes sense given its purpose. You can place a base view anywhere on the sheet and adjust appearance settings like orientation, style, and scale easily. Note that the style setting updates automatically after placing the view. We're keeping things simple here, focusing on a basic drawing without diving into all the advanced options. That's a topic for another time. To add another base view, just click the base view button in the top left corner. You can continue adjusting the settings even after placing the base view on the sheet. Let's fast forward a bit while briefly demonstrating the different orientation settings. Let's add a final base view with a 2:1 scale and a solid appearance. This clearly highlights our design from this perspective. To edit the view, simply click it on the sheet to reopen its settings. The shaded style displays the brass appearance nicely, and the shaded with hidden edges option can be helpful for a clearer understanding of the model's structure. Great job following along. Let's wrap this up by adding manual and automated dimensions. Manual dimensions are just as easy to place in the drawing workspace as they are in the modeling workspace. Simply select specific points or angles. Auto dimensions offer different setups. Choose what fits your design best. You can also adjust the density of dimensions, meaning the number of dimensions shown, scaling it up or down as needed. We're not diving into whether these dimensions are ideal for this particular design. The goal here is to show useful tips and tricks. Before exporting, remember to save your drawing. Tick the box to automatically open the file after export for a faster workflow if you plan to review it right away. I hope you enjoyed this tutorial, and I look forward to seeing you in future lessons where you'll pick up more valuable workflows, tips, and tricks. Here are 2 videos you'll enjoy if you like this one.